Test. All right, good. Okay, good morning, everyone. We are down to our last week before finals. So just a reminder, our final is on Wednesday, the 12th, next week, 9 a.m. to 11:45 a.m. And today, I told you last week that we're pretty much going to stop with the material and just begin reviewing. The only things that we kind of didn't get to were the parabola and ellipses. So this stuff will probably come up again a little bit in Cal 2, Cal 3. But I think these are things where if you did a review of these, or if you watch some videos or something, you probably get a grasp on this. You did study the parabola in college algebra, but you pretty much focused on only parabolas that open straight, like up and down. This section includes parabolas that go left and right. And then ellipses, that's kind of like an extension of what a circle is. So those are the two sections that we're not going to really get to, but I think you'll be fine without them, at least in Cal 1 and Cal 2. All right, so today we are going to go over an old final. And then after today, after class, I'm going to send you through email another final from the past. And then on Wednesday, we'll go over either the one I sent you or a completely different one. They're all very similar. But today is just going to be me working and asking you for guidance as I work through the problems. And then on Wednesday, hopefully it'll be more of like questions from you as opposed to me just doing problems. So here we go. Here's a final that I gave, what is that, 4 years ago? And it covers pretty much the whole semester. There's things I don't test on. There's things that I emphasize a little more than others. Let's see how many problems there are here. There are 22 problems on this test. So what I'd like to do is just work through this, okay? And you're gonna have to go way back into the cracks of your memory to try and recall how to do all this stuff. So, all right, ready? Here we go. All right, so the first question asks us to find the center and radius of a circle, and we're given the equation of a circle. So a few things that you have to remember here, and you know what, this might be a good time for us to talk about what you're going to have on the final. So I'm going to allow you. Michael's asking if this review is up on Canvas. This is not. I can send it in the chat if y'all want it, just so you can have it.
No, I meant the review for the final, like for our final, like the review.
Well, that's what this is. This is what we're doing. I mean,
okay.
I'm going to be giving you like 3 different old exams. Though, consider those to be your review.
Oh, okay.
Yeah. But I still will send this to everyone right now, just in case you want it. Let me see if I can find where I am here. Yeah, I had thought about, I was going to send you all a review on Friday. And I was like, you know what, I'm just going to give them the weekend to not think about it and just kind of enjoy your last weekend before finals start to come. Okay, I just sent it to everyone. If you didn't get it, don't worry, I'll email it to you later. Okay, so on the final, of course, you can have your formula sheets, but in addition to the formula sheet, I'm going to allow you to create your own formula sheet. Okay, just a standard sheet of paper, front and back. And what you can put on this paper is pretty much anything you want except for worked out problems. So you can, any formulas that, as we go through these reviews, any like hints or steps or procedures, anything that you want to put on here, like, hey, remember when trying to find the center and radius of a circle, use this, but you can't have anything worked out. But you can have steps and procedures, okay? So you'll have that in addition to your formulas.
Could we draw the unit circle on there?
Let me think about that. I mean, I really want all of you to do well in calculus, and to do well in calculus, you can't have your unit circle. You're not going to have a unit circle, so it's got to be something that you've got kind of in here. Let me think about it. Let me think about it. Right now, the answer is no, but then that kind of contradicts me saying you can put anything on there except worked out problems. But I could consider the unit circle a worked out problem, I guess, if I wanted to. Okay, let's get into this. We have 22 problems. I don't know if I can do this all in one day. So, all right, here we go. Finding the center and radius of a circle. So the thing that you need to know here is that if we're given the equation, we've got to eventually get this to look like this. And that's the standard form of a circle. And if we can get it to look like that, then the center will be whatever the H and K are. And then, of course, the radius will just be the R. Does anyone remember how to do this?
It's been a minute.
You start by moving the 18 over to the other side, right?
You can move the 18 over to the other side. You can also collect your X terms together and your Y terms together. See, the problem is right now, the way that the equation looks, it doesn't look like X minus a number squared plus Y minus a number squared. We have the X here, we have an X squared, but we have an X here, and then we have a Y squared, but we have a Y there. So we have to
factor out
complete the square. Completing of the square. Does that ring a bell? It's been a long time since we've done this. So what I'm going to do is I'm going to focus just on the X terms first. And I look at the number in front of X, which is 2. Now remember, I'm going to be working through this today as if this is a review. I'm not going to reteach this. So I'm going to go through a procedure. If you're like, oh my gosh, I don't remember any of that, then that's why we're doing this, all right? Okay, so what I do is I take the number 2, put it over here. I take half of it, which gives me 1. That's what I refer to as a magic number. And then we take that 1 and we square it, which leaves us with 1. That's our second magic number. And then what we do is we rewrite X squared plus 2X. And now we use the second magic number, we add it and we subtract it. And then we do the same thing for the Y's. We take the -4, we take half of it, which gives us -2. We take that -2 and we square it, that gives us 4. So we're going to add that 4 and subtract that 4. And then we still have the 18 on the other side. Now, the whole reason we do that is because the first 3 terms here on both the X and the Y's will guarantee to be a perfect square trinomial. So it will factor. This becomes X plus 1 squared. Those are the first 3 terms. And then we still have the -1. And then these 3 terms will factor to be X, not X, Y minus 2 squared. Then we still have the -4 equals 18. And now I'm just going to move the -1, add it to both sides, and then take the -4 and add it to both sides. So we're going to basically wind up adding 5 to this, which gives us 23. And that's it. This now looks like that. So the center for us will be -1, +2. Okay, that's the opposite of this number, -1, and then this is exactly minus, so K is 2. And then be careful here, the radius is, if this is the radius squared, then the radius will be the square root of that. So the radius is the square root of 23. There it is. Questions? Okay, a man runs around a circular track which has a radius of 200 feet. he completes 1 full lap in 4 minutes. Okay, so he starts at a point, goes around, right? It takes him 4 minutes to go all the way around. First question is find his angular speed. Okay, now if you go back in our notes, we call that omega. And omega is always theta, the angle that you go through, divided by the time it takes you to do that. So for this person, they are running, they're going around this track. It takes them 4 minutes to go around once. And one time around is 360 degrees. But notice it says find his angular speed measured in radians per minute. So I want to convert the angle 360 degrees into radians. That's 2 pi divided by how long it takes them to go 2 pi, which is 4 minutes. And so you get, let me see here. How do I want to do this? Let me just rewrite this first. This is pi over 2 minutes. Just simplifying that. And then I'll go ahead and get on my calculator. I'm going to go pi divided by 2. Yeah, that's about what the hell is that? 1.57 radians per minute. Now, what's a little tricky about that is that, remember, in the numerator, your angle is measured in radians. Normally, we don't put radians, right? We only put the degree symbol if it's a degree. If you don't put the degree symbol, then it's understood to be radians. But here, I think it's important to put radians per minute because you want to make sure it's a rate, right? It's an angular speed, so it's a rate that something's happening. This guy is traveling 1.57 radians every minute. Now, how do we find his linear speed? Does anyone remember the formula for this?
V is equal to R times W.
V is equal to R times W, which is omega, right? So this, again, may be something that you need. So we have the radius, don't we? Which is 200. And we have the omega, which is his angular speed, which we just got, which is 1.57 radians a minute. And now when you multiply that, you multiply 200 times 1.57, and you get 314 feet per minute. Now that's using a formula to get this answer. I like to consider this a slightly different way. I mean, this is fine and we get the answer, but just like moving on in your life in math, instead of just relying on formulas, just if you're trying to figure out his linear speed, think about it this way. If you were to take that circle and just cut it, okay, and lay it out flat, okay, then it took him 4 minutes to go this distance from one point to the other, which is the distance all the way around. But isn't this distance just the circumference of the circle? It's the circumference, isn't it? Okay, what's the circumference of any circle? 2 pi r, right? 2 pi times the radius, which would be 2 pi times 200, sorry, feet. So this is 400 pi feet. Understood? Feet. So the distance he traveled, right? How far did he go? He went 400 pi feet. How long did it take him to do that? 4 minutes, right? So his speed should be the distance he travels divided by the time it took him to travel that distance. And if you do 400 divided by 4, you'll get approximately, you have to do it on your calculator. It's 100 pi feet per minute, which is about 314. So two different ways of going about the problem, all right? Okay. Find the height of the Tower of Americas. So I hope it's obvious that we have a right triangle here. We've measured that the distance from here to here is 98 feet and measured that this angle is 81 degrees. And we want to know how tall it is. We'll call this height. So how can we do that? We have one angle, one side, and we're trying to find the opposite side, and we are on a right triangle. So don't be thinking law of sines and cosines and all that. We are on the right triangle. Josh, did you want to say something?
Yeah, I would just use tan. I would just
Tangent?
yeah.
So yeah, the fact that we know that tangent of an angle, 81 degrees in this case, will always be the opposite side, which is h, divided by the adjacent side, which is 98. And there we have an equation with h in it, right? So we just multiply both sides by 98. We have h. So we'll need our calculator for this. We'll need to make sure we're in degree mode. I'm getting approximately 618.75 feet is h. Questions there? Find the exact value of the remaining trigonometric functions. If cosine of theta is -4/7, sine theta is greater than 0. All right, so I think this might be a good time for us to look at what formulas I would be using here. I'm going to go with this right here. Whoa, that's big. Come on, man. Doesn't want to come in here. It doesn't want to play with us. Okay, well, then it's gone. Okay, so I'm going to be using those formulas. Maybe I can stick it here. It doesn't like it. Okay, so I'm going to be using these formulas that if we're given an angle, and this can be in any quadrant, doesn't have to be in the first quadrant, that we have sine is the y over the r, cosine is x over r, tangent is y over x. And then these are just the reciprocals. So I'm going to use that now. And first thing I'm going to do is try and figure out what quadrant I'm in. So very important, cosine of the angle is negative. Cosine can only be negative in which quadrants?
2 and 3.
2 and 3. So I'm going to eliminate quadrants 1 and 4. Okay, I've got to be there. Now, the next thing I'm given is that sine of the angle is positive. Sine can only be positive in the first and the second quadrants. So I know I'm not in the third or my fourth. Okay. All right, so that means I've got to be in this quadrant over here. Now, that's important because this information here tells me, remember, cosine of an angle is the x over the r. So I know that the x must be the -4. The r here, of course, has to be the positive, but this matches up with where I am. To the left, right, x is -4. And then that means my y is going to have to be positive. Now you'll see that in the next step. If that's x and r, then I know from the Pythagorean x squared plus y squared equals r squared, I can replace x with -4, can replace r with 7, and so I get 16 plus y squared equals 49. Subtract 16 on both sides. So what do we get there? 33. Y squared is 33. So y must be, and this is the part that was important, plus or minus root 33. But it has to be the plus, because we're talking about the y coordinate and we're in the second quadrant, which means we're above the x-axis. So it must be the positive root 33. Okay, once we know that, we can get all the trig functions, because we know right now that x is equal to -4. We know y is equal to positive root 33, and we know that r is equal to 7. So if we want to know what sine theta is, it's the y over r. Cosine theta, we already knew that because it was given to us. And then tangent theta will be the y over the x. And then I trust that you all can just flip all those over to get the other three, right? Cosecant, secant, and cotangent, just flip all those answers. Questions there? Okay. For what values of theta is f of theta equal cosecant theta not defined? So I'm defining a function f of theta as cosecant theta, and I'm asking you, when is this function not defined? So it might help if we rewrite that function, in terms of sine and cosine. Cosecant is 1 over sine of theta. And so when is this going to have a problem? Whenever what?
Whenever we hit 0.
Whenever sine theta is 0, right? So if sine theta is 0, we should probably look at that. So when is sine theta 0? Well,
0.
you
0.
go ahead.
It's 0 at 0 and pi.
0 and pi. Here at 0, sine of any angle at 0 is 0. And then here at pi is another place where this is 0. And we want the general solutions, or general solution. So I need all possible angles that land at this point or this point. So this is where you say theta equals, and then notice that these are directly across from one another. So you can just jump back and forth, right? You have to jump by pi each time. So I'm going to start at 0, that's pointing out to the right, and then I'm going to just add multiples of pi. So pi k. And you don't need the 0 there, so you can just put pi k. So any multiple of pi is where this thing is undefined. Questions there? Okay, sketch this function, follow the procedure covered in class, clearly label important points and axes. All right, so we are graphing -3 secant of 2x plus pi over 4. So for me, what I'm going to do is I'm actually going to graph cosine. This same thing, but cosine. And I'm doing cosine because secant is the reciprocal of cosine. And I'm going to just remember that this -3 means that my amplitude must be 3, and I'm going to be flipped over the x-axis. Look, everyone, I realize that this might be more useful or beneficial to you if you were the one working through this, but that's why I'm going to give you another review for you to do for homework, and then we can come back on Wednesday and wrap up anything that you have questions on. I think if you can do this and the one I give you, the one we cover on Wednesday, I think you'll be fine for the final. Okay, so now let me graph this. How do we do this again? We're graphing cosine. So we have to basically know what cosine looks like. Like generally speaking, cosine looks like this. it has these important points, right? It has these important points on the graph. It starts here, crosses down, crosses up. So we want to try and find those points. So this is where we take the argument of the function. Oops, this one. And we're going to take that and we're going to set it equal to 0 and 2 pi. That's the standard procedure. Notice that I'm not going and finding the period and all that stuff. I'm not phase shift. I'm not even doing any of that. That's not the way I did in class. What I did was this. So just be careful on these. Make sure you get your signs right. So move the pi over 4 to the other side and then divide by 2 gives you negative pi over 8. And oops, I forgot to put equals 2 pi here. So subtract pi over 4 from both sides again. Let me see, that's going to be 8 pi over 4 minus pi over 4. So if you're going to subtract pi over 4 on both sides, you have to turn 2 pi into 8 pi over 4. This gives you 7 pi over 4. And then when you divide that by 2, you get 7 pi over 8. So in terms of like my general picture, like this was my general picture, I know that the starting point here is negative pi over 8, and I know that the ending point here is 7 pi over 8, but I'm gonna start with a new graph, okay? So this is actually negative pi over 8, somewhere to the left of the y-axis. And then 7 pi over 8, I'm just going to put over here somewhere. Okay, that's not enough. We now need to find the other important points, which I'm going to label in blue. We need those points right there. We already found the 2 endpoints, but now we need to find these. So the way we did that is we found the one in the middle first. And the one in the middle, how do we get the number between 2 numbers?
Add them and then divide
Add
them.
them and divide by 2, right? Take their average. So we're going to take negative pi over 8. We're going to add 7 pi over 8. We're going to divide by 2. I remember on grading the test, a lot of people did this, but they forgot to divide by 2. So they just added them up. Let's see. This gives me 6 pi over 8 divided by 2. This is, let's see, 3 pi over 4 divided by 2. And if we take that 2 on the bottom and look at it as a 2 over 1 and then multiply by the reciprocal, you should get 3 pi over 8. Now we have to find the number that's in between these 2 numbers. So I'm going to do the same thing, negative pi over 8 plus 3 pi over 8 all over 2. So this gives me 2 pi over 8 over 2. And when I'm done with that, I'm not going to show the work. That should just be pi over 8, which is, wow, okay, this doesn't look very good anymore. Pi over 8 is right in the middle of those. My y-axis is further over here. It's okay if you have to, you know, that's why we write in pencil, right? In case we need to move things around. All right, and then last one, I need this one here. So that's going to be take 3 pi over 8 plus 7 pi over 8. Now look, I realize that some of you know that there's kind of like once you get this, like there's an easy way to do this. Like there's a way that I know this is 5 pi over 8 because every time I jump, jumping by 2 pi over 8, right? To go from -1 to +1 or 1 to 3, it should be. But this is important. I mean, just as a math person, you should know how to find the number in between 2 numbers. Okay, so this one, when you finish it all out, should be 5 pi over 8. Okay, so that's 5 pi over 8. Okay, so we're ready to start putting this together. Now we need to remember that the amplitude was 3 and we flip it over the x-axis. So I'm going to put 3 here and -3 here. And it's a cosine function. So it's supposed to start here. Don't draw this. It's supposed to start here. It's supposed to go like this. This is what it's supposed to do. but we have to flip it, right? We have to flip it over. So it's actually going to start, I'm going to do it in blue. It's going to start here. And I'm also going to draw it dotted because this is not my final picture. Good enough. Remember, these look like little smiles and frowns, right? They don't look like V's. Once I've done that, anywhere that it crosses the x-axis, that creates my vertical asymptotes for the cosecant, I'm sorry, for the secant function, which is what I'm eventually trying to draw. Ultimately, I'm trying to draw the secant function. And now we just need to remember how this works. We're going to start at the highest point here. We're going to draw a U that sticks in between the vertical asymptotes. And then on these, you can't draw the full U. I'm just going to draw half of the U here. And then from this point, half of the U like this. I mean, technically it does go the other way, but we didn't include that part of our graph. Like we didn't go get these over here. So you don't need to do that. Just draw from there to there, there to there. And that is it. So this to me would be a perfect score because your graph is labeled, everything's correct. I can see the amplitude. I can clearly see its cosine that's been flipped. I can see your vertical asymptotes. I can see where you got your starting and ending. I can see where you got your middle points. Okay. If you just draw this for me on the test and be like, oh, that's it, you know, like just what you saw on your graphing calculator screen, like that's not going to work. Like you have to have work for this. Okay.
I have a quick question.
Mhm.
On the homework, do we still do the ellipse and parabola problems?
No, don't do the ellipse and parabola.
Okay.
We're pretty much done with the online homework stuff. Okay, find the exact value of tangent inverse of tangent of -7 pi over 8. Okay, so I'm supposed to do this without a calculator. So on the test, what I'm trying to see is whether or not you're going to just put these two together and cancel them because they're inverses. Whether or not you're just going to cancel these and give me an answer -7 pi over 8 without doing any thinking. So here's the proper way to approach this. We need to figure out what quadrant we're in. And the reason why we have to do that is because we're dealing with the inverse tangent. And we know that with the inverse tangent, well, we should know with inverse tangent, you're only working in the first and fourth quadrants. So let's look at where -7 pi over 8 is. Okay, now that's not a common angle, right? -7 pi over 8. And it's also an angle it's negative, so it's a clockwise angle. So where is it? Where is it is really the big question. So if I start rotating, I'm going to stop somewhere around here. This is the angle I'm dealing with. Now, the reason I know that is because if I went a little bit more, -8 pi over 8, that would be negative pi, wouldn't it? Which would be just all the way to the x-axis on the other side. So this should be -7 pi over 8. Are there any questions on how I know I'm in the third quadrant? No? Now this point, whatever it is, has an x and a y coordinate. Do y'all agree? Okay. When you take tangent of that, you are going to get the y divided by the x, correct? Okay. Now, when you do that, you then need to take inverse tangent, which should spit back the angle. But the problem is this inverse tangent function cannot spit back this angle because this angle is not allowed. So what angle is it going to give you? It's going to be the one straight across in the first quadrant, because over here, the x and the y, the only difference between this x, is that this one is negative and this one is positive. And then the difference between the y's is that this one's negative, that one's positive, right? So this one is negative and that one is positive. So again, on your calculator, if you were to do tangent, just think about this. If you were to do tangent of this angle, it would be that y divided by that x. And a negative divided by negative would be positive. But that would be the same as doing tangent of this angle, because the only difference between these two is that these are both positive. So this y distance is the same as that y distance, except that it's positive and negative. They're just opposite in sign. And then the distance across here, that and this are the same. They're just opposite in sign. So what would my answer be? What's this angle from here to here? What do you think? Couldn't you just take this? We need to get a positive angle out of this. So that total distance straight across is pi. So why don't I just add pi to it? And that would take me, adding pi would take me to that side. So this will be negative 7 pi over 8 plus 8 pi over 8 common denominator, which is pi over 8. So the correct answer here is pi over 8. These are these types of problems that can really hurt you on a test, because if you get it wrong, like it's just like wrong. There's no like partial credit for these, you know? And so if you just put the answer, oh, these just cancel each other out, negative 7 pi over 8, I have to take off pretty much full points for that. I mean, I guess what I'm saying is you could do a problem like this and mess up one little thing in here, and you're only going to get a couple of little points off, right? Because there's a lot to do here. There's a lot of opportunity for partial credit. Here, there's really not a lot of opportunity for partial credit. You either understand this or you don't. So those types of things add up. Okay, questions? Next one, find the exact value of cosecant of tangent inverse of negative 4/5. Okay. This problem is different, right? It's different in a couple of ways. We don't have the same trig functions, right? It's not tangent, inverse tangent. It's not the same. And notice on this one, the inverse is on the outside and the regular tangent function is on the inside. Here, the regular function is on the outside and the inverse tangent's on the inside. So what I'm going to do is I'm going to remember that anytime we talk about inverse tangent of something, or inverse sine or cosine or tangent, that's always going to spit back to you an angle theta. All right. So ultimately here, what we want to know, right? What do we want to know? We want to know what cosecant of theta is. Do y'all agree? If we can find out what cosecant of theta is, we're done. So over here, I'm going to write theta equals, well, what are we saying theta is? Theta is arctangent or inverse tangent of negative 4/5. And if we take that and take tangent on both sides, so take tangent on the left, tangent on the right, we should get negative 4/5 on the right. So taking tangent on both sides. Now we do have a problem though. We know that we have to be in the first or fourth quadrants because we're dealing with inverse tangent. And we also know that tangent is, tangent is always your y divided by your x. So where are we?
We have
Be
to
the fourth.
fourth, yeah.
We have to be in the fourth?
Yeah.
So you're saying that the y here is negative 4 and the x here is positive 5?
It would have to be, otherwise everything would be positive. If we were in the first quadrant, everything would be positive.
Yeah, so if we were in the first quadrant, they'd both have to be positive. Now, the negative here, though, couldn't I have written this as 4 over negative 5? That's the same thing, isn't it?
Yep.
And then your y would be 4 and your x would be what? Negative 5. Why is that not possible?
Because that would throw us into the second or third quadrant.
That puts you in the second quadrant, right? If y is 4, we're up 4, but x is -5, we're over here. So it can't be this. You just have to be careful. The placement of that negative is not fixed. It can be on the top or bottom. We know it has to be the top one because of the inverse tangent in the restriction. So I know that I am x is 5 and y is -4. Okay, that's where I am. The x is 5 and the y is -4. Now, what I'm going to do now is I'm going to find the r. What's the radius? Okay, so what I'm doing is kind of like, I'm kind of building the triangle, but I'm using more of the general definition of the trig functions. I know that x squared plus y squared equals r squared. So 25 plus 16 equals r squared. That's 30. 41 is r squared. And square root of 41 is r. And it has to be the positive because we're talking about r. So we know everything. We know x is 5. We know that y is -4. And we know that, and we're talking about the angle theta here, right? Theta is what represents, theta is the angle that we're referencing here. So cosecant of theta. What is cosecant by definition? Well, it's the reciprocal of sine, isn't it? And sine is the y over the r, right? The y divided by the y divided by r. And so the reciprocal of that would be r over y. So this goes back again to these formulas right here. Cosecant theta is r over y. And I know what r is. And I know that y is -4. So I'm going to do this on my calculator. Okay, because it says don't do it with your calculator. I'm going to do it on my calculator right now. Inverse tangent of -4 divided by 5. And then I'm going to take sine of that. So if I do this on my calculator, I get -1.60078. So that's if I try and type all that into my calculator. Now, if I take the square root of 41 and divide it by -4, I get the same answer. Okay, I get that answer. If you give me this decimal answer without doing any of this work, you won't get any credit. Okay, it's not about getting the answer. It's about understanding how we break things down, restrictions on inverse trig functions. How do we arrive at this, right? So just pay attention to the directions. If I say without a calculator and you get the right answer without work, you're not getting credit. I'm only saying this because students do this, right? And then I'm like, why did they? Okay. All right, here we go. Find the general solutions for this. Why don't I give you a minute? See if you can remember how to do this. I'll give you, how about I give you like 4 minutes to see how far you can go with this. Sound good? I put the answer up there just so you can kind of check to see how you're doing. That's been about 4 minutes. So I'm trying to find the solutions to a trigonometric equation. So the first thing I notice, I've got 10 squared, so I'm probably going to need a square root. I'm going to move the 1 over. You could have done a difference of squares here, but I just moved the 1 over. Then I took the square root. Very important that you do plus or minus. And this is the critical point right here. What we're saying is when is tangent positive or negative 1? And you have to remember that that happens at these 4 corners, these diagonal corners, because on the unit circle, that's where you have root 2 over 2, root 2 over 2. And then over here you have negative root 2 over 2, root 2 over 2. And then here you have, they're both negative root 2 over 2, root 2 over 2 negative. And then I may as well. This one is root 2 over 2 and negative root 2 over 2. So because tangent is always your y divided by your x, at each of these 4 corners, you have the same numbers. They just maybe differ by sign. So here you get 1 if you did y divided by x, and here you get negative 1, here you get positive 1, here you get negative 1. So I'm saying all the solutions to this are whenever we're at these 4 corners. And I say, okay, well, I noticed that these corners, if I just start at pi over 4, if I start at this angle, then I can just jump by pi over 2 to move my way through these answers and just keep jumping by pi over 2 each time. So now I take my argument and I set it equal to that general solution. Pi over 4 is where I start, and then jump by pi over 2, then divide by 3. And then this right here, all I did was got a common denominator between these two. Any questions there?
Would it be acceptable if you had pi over 4 plus pi k and 3 pi over 4 plus pi k?
Like do it as 2 different things, that would be okay.
Okay.
So what Anna Marie is saying is, instead of looking at it as jumping by pi over 2 each time, she looks at it as 2 different sets of answers. Like here and here, that's where we get 1, right? That's where tangent is 1. And so you can start at pi over 4 and then jump by pi instead. So you get 3 theta equals pi over 4 plus pi k. And then look at it as a separate problem here and here as being going to 3 pi over 4 and then jumping by pi. So all you have to do is divide these by 3. I think that's what you said, right, Anna Marie?
Yes, sir.
Yes. Okay, yeah, so that would work also. Divide by 3 on those and you'd be fine. All right, any questions on that? Okay, number 10 is the same type of problem in the sense that we want to find solutions to a trigonometric equation. But this time we're given a restriction, so we want to actually list out the answers. And our trig equation is a little more complicated. So we have 2 sine squared theta equals 3 minus 3 cosine theta. So I noticed that I've got a sine squared in here, and then I've got a cosine. So I don't even have the same trig function in here. So I'm going to start out by trying to get this all in terms of the same trig function. So I'm going to try and get it in terms of cosine because I have this Pythagorean identity that sine squared theta plus cosine squared theta equals 1. That's the big daddy, right? So I can solve this for sine squared theta and get 1 minus cosine squared theta. And that's what I'm going to do. I'm going to replace that sine squared theta with 1 minus cosine squared theta. Very important that that 2 sits in front and must distribute to both of those terms, right? So the 2 must go here and here. Now I have a quadratic equation in terms of cosine. Everything's in terms of cosine. So I'm going to move everything over to the, I'm going to move it to the right because I have a negative in front of this. I'm going to move everything over to the right-hand side. So I'm going to have 0 equals, I'll have my 2 cosine squared theta. I'll have my minus 3 cosine theta. And then when I subtract 2 on both sides, I get +1. Now, if you don't like the way that looks, you can put the 0 on the other side. It doesn't change anything at all. And now I'm going to try and factor this because that looks a lot like a quadratic, right? So I try and factor this. So I guess mentally, here's what I'm trying to do. I'm trying to really factor something that looks like this. So yeah, you've got to be able to factor. Let's see, 2x, x, -1, -1, I believe works. Yeah. So this is going to become 2 cosine theta -1, and then cosine theta +1. Questions? Now that I have it factored, I set each factor equal to 0, 2 cosine theta -1 equals 0, and cosine theta +1 equals 0.
Wouldn't that last bracket, wouldn't that have to be -1, cosine theta -1?
Oh, did I? Oops, I wrote it down right over here. I don't know why I didn't put minus here. Thank you. Glad you caught that. Yeah, that's minus. Put it here, but not here. All right, 2 cosine theta equals 1. Move the 1 to the other side, divide by 2. Cosine theta is 1/2. And here cosine theta is 1. Now, because my argument is not like 2 theta or 3 theta or something weird, it's just theta, I can now just look at the unit circle. Because our answers we wanted were between 0 and 2 pi. So I can just look for all the places where that happens just on the unit circle and between 0 and 2 pi. So cosine is the x coordinate, and I want to know where it's 1/2. So you just need to know this. Happens up here at pi over 3. Also happens down here. And that angle is 5 pi over 3. And then, so my answer so far, theta equals pi over 3 and 5 pi over 3. It's 2 of my answers. And then here I want to know where cosine of theta is 1. Okay, so cosine is the x coordinate. That happens here at 0. And let's see, do we want to include 2 pi? So theta greater than or equal to 0, but less than 2 pi. So I don't want to include 2 pi because I could come around again, but I'm not supposed to go to 2 pi. So my only answer over here is theta is 0. So there are only 3 solutions here. These 2 and that one. Questions? We're doing pretty good. Okay.
Do you not have
Identity.
to add 2 pi k to the answers on that last one?
No, because it gave us an interval. So here
Oh.
they gave us, they wanted an interval, like in here, give me only the answers in there, as opposed to the previous one, which was general solutions.
Gotcha.
So those are like the keywords you want to look for during the test. If you see general, you know you're going to have like a K somewhere in there. If you're given an interval, then that means you're going to just list out whatever answers you have, and you'll have a finite number of answers. Okay, identities. Show that the left-hand side is equal to the right-hand side. So you got to start with one of the sides and turn it into the other. So which side would you like to start with? I don't care.
I think the right side to
You want
get
to start with the right?
the theta
Okay,
out,
so we
yeah.
start with the right. Let's write it down. We need to see if we can turn the right-hand side into the left-hand side. So how would you start this out?
By converting the cotangent to cosine over sine.
Okay, you can do that. Cosine theta over sine theta. Okay, I agree. We could do that, right? Just rewrite cotangent in terms of sine and cosine. All right, now's the tricky part. Remember, look at where we're trying to get. We're trying to get to this, right? Does anybody see it?
Get a common denominator on the bottom.
Okay, we can try and get a common denominator on the bottom. That's a legal move. We can do that. So if we do that, we're gonna have to look at that 1 as 1 over 1 and then put those together by getting a sine on top and bottom. So we'll have sine theta over sine theta minus cosine theta over sine theta, which is 1 over sine theta minus cosine theta over sine theta, our common denominator. Now what?
Then to get rid of the fraction on the bottom, you multiply by the reciprocal.
Yeah, so if you have 1 over a fraction, right, that's what we ultimately have here. We have 1 divided by a fraction. That's the same as 1 times the reciprocal. So if I just do the reciprocal, we're there. Right? I mean, that's the left-hand side. I'll show you another way you could have done it. At this point right here, when we had 1 over 1 minus cosine theta over sine theta, if you just squint your eyes, just the right squint, you'll see that to get the left-hand side, I need a sine here, and no signs on this, right? So I need this to be a sine, that to be a sine, and I don't want the sine here. So I could have just multiplied the top by sine and the bottom by sine. And on the top, it just becomes sine theta. And on the bottom, you distribute. And when you hit the 1, you get sine theta. And when you hit this one, the signs cancel and you get cosine theta. And that's your left-hand side. Just another way of doing it. How about starting with the left-hand side? What if we started with this? This one's a little harder, but I think if you know where you're trying to get to, this is actually not that bad.
You would split it into 2 separate fractions. So it'd be sine of theta over sine of theta minus sine of theta over cosine theta.
Say again, sine theta over, oh, you want to do sine, wait, hold on, what?
Oh, wait, no, sorry. I was thinking backwards. Never mind.
Yeah, if it's backwards, we can, right? So be careful. You can't go this over this and this over this. Look at where we're trying to go, though. Look, so we don't want a sine theta here anymore, right? We want a 1. We don't want a sine theta here. We want a 1. And we don't want cosine. We want cotangent, but cotangent is cosine over sine. So couldn't we just divide all of these by sine? Just multiply that by 1 over sine theta, 1 over sine theta. It's almost like what I did on this one, but backwards. So when I multiply here to here, I get 1. And then here I distribute, and I get 1 minus, and then cosine theta over sine theta. And that's your answer. That's your right-hand side. So this is if you started with the left-hand side, turn it into the right-hand side over here. Okay, whatever. I mean, you've experienced these problems before. You realize that they're all different. They all require something unique. All right. Whoa. If tangent of alpha is 4/3 and alpha is between pi and 3 pi over 2, and cosine of beta is -1/3, and beta is between pi/2 and pi, then find cosine of alpha minus beta. All right, cosine of alpha minus beta is what we're trying to find. So going to my formula sheet, cosine of alpha minus beta is right here. Cosine of alpha minus beta would be cosine alpha cosine beta plus sine alpha sine beta. So I'm going to use that formula. I'm going to go ahead and write it down here. This turns into cosine alpha cosine beta plus sine alpha sine beta. Now, if we look at this, what do we have? Well, tangent alpha, I don't have sine of alpha or cosine alpha, I have tangent alpha. I have cosine beta, so I do have that one, right? I have cosine beta. I've got one of the four things I need. So this problem is all about reference triangle stuff. Okay, so let's start with this first one. Tangent of alpha is 4/3. And draw my plane. Let's figure out what quadrant we're in. We're between pi and 3/2, so we are not here and not here, right? So we've got to be down here somewhere. And tangent of alpha is 4/3. Oh, wait a minute, hold on. Tangent is supposed to be the y over the x. How is it possible that if we're in the third quadrant, how is it possible that we get +4, +3 for our y and our x if we're in the third quadrant?
The y and x are both negative.
Yeah, we have to realize that this is showing it with the negatives canceled. We need to deduce from this that the y has to be here, then a -4, and that the x here for us has to be a -3. And the only way we know that is because we're in the third quadrant, where both the x and y have to be negative. So this is -3 and -4. Do y'all see how that's tricky? If you're not paying attention to the restriction on the angle, you may think you're in the first quadrant when you're not. No? Oh, yeah, no. So from this, can I figure out what cosine of alpha is in sine of alpha? Can I figure that out? What am I missing?
R.
R. We got to figure out what R is. So I know that x squared plus y squared is r squared. So -3 squared plus -4 squared must equal r squared. So 9 plus 16 is r squared. So 25 is r squared. So r is 5. And it's got to be positive because it's r. Now that's important because now we have everything, right? We have x, y, and r. So I can tell you any of the trig functions now. So if I want to know what sine of alpha is, it's the y divided by the r. If I want to know what cosine of alpha is, it's the x divided by the r. And that's good because I needed cosine alpha and sine alpha in here. Now we have to do the same thing for beta. So for beta, so this all over here, this was all alpha. Now I'm going to go figure out the stuff for beta. So cosine of beta, let's see where we are. We are in the pi/2 to pi, so we are in the second quadrant. We have some point over here that has an x and a y coordinate. We're given that cosine of beta is -1/3, but that must mean that the -1 is on the top and the 3 is on the bottom because cosine is your x over your r. This means my x is -1, and that means my r is 3. So I need to get y, right? Because we're going to need to know what sine of beta is. Sine of beta is y over r. So same story, x squared plus y squared is r squared. So -1 squared plus, we don't know y, so y squared equals 3 squared. So 1 plus y squared is 9. Y squared is 8. Y equals plus or minus root 8. And which one is it? Is it plus or minus?
Plus.
It's plus because we're in the second quadrant. So the y value is positive there. So it must be y is root 8. All right, we have x, we have r, we have y. So now we can write down sine of beta is the y divided by the r, which was 3. And we needed cosine beta up there, but they already gave us cosine beta, but we can still get it from here. It's -1/3. Questions? We're almost to the answer here. This will be equal to, okay, cosine of alpha, which was here, -3/5, times cosine of beta, which is -1/3, plus sine of alpha, which is -4/5, times sine of beta, which is root 8/3. All right, order of operations, do these multiplications first. So just go straight across, 3/15 minus 4√8/15. So I multiplied those across and I just carried the negative out front. And then I'll get a common denominator, or there already is a common denominator. That is the answer. 3 minus 4√8/15. Questions? We haven't fun yet. We're about halfway, a little bit more than halfway. We've been at this for a little over an hour. So this problem here caused all sorts of problems on the last test for people. And I want to also point out to you that I asked you for cosine of alpha minus beta here. There's a lot of things I could have asked you for that would have required the same work. On one of the other test things I'm going to give you, let me see if I have it here. I think there's another one where I have, nah. Okay, we'll get to it later. All right, this problem caused all sorts of grief again on the previous exam. So find the exact value of sine inverse of 4/5 minus arctangent of 3/4. And the thing I think people failed to see on this was that, again, anytime you have an inverse trig function, this spits out an angle. So I'm going to call that angle alpha. I could have called it whatever I want, theta, but I'm going to call it alpha. And this is another inverse trig function. I'm going to say that that's beta. So ultimately, what we're trying to find is sine, right? That's sine of what? I'm going to use parentheses instead of brackets. Alpha minus beta. That's what we're trying to find. Sine of alpha minus beta. And then you go to your formulas. Sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. So I'm going to use that formula there. So this should be equal to sine alpha cosine beta minus sine beta cosine alpha. So we need to know what sine alpha is, cosine beta, sine beta, cosine alpha. Right, we need all those. But it's not like the previous problem. It's not like the previous problem where we did these, like they gave us all this information, right? Like here we had all this information about these. Here we don't have all this information. We actually have to extract that information from the given information. So let's start with alpha. Let's just look at this. We know that alpha is sine inverse of 4/5. Now, that means that sine of alpha is 4/5. And we know that alpha is in the first or the fourth quadrant. We know it's in the first or fourth quadrant because we're dealing with the inverse trig function, which restricts us between negative pi over 2 and pi over 2. So can we tell even more whether or not it's the first or fourth?
The first.
Has to be the first, because sine can only be positive, right? Sine of an angle can only be positive in the first or second quadrants. We can't be in the second, so I can eliminate this. So here's what I know. This point right here has an x and y coordinate. I know that the y coordinate over the radius, or r, is going to be the 4 over the 5, right? So y is 4 and r is 5. And then we're going to just play the same game that we played a minute ago. We're going to find, x squared plus y squared equals r squared. So x we don't know, plus y is 4 squared equals the radius squared. I'm going to work this out. You should get plus or minus 3, but it has to be plus because we are in the first quadrant. Can't be negative.
I have a question.
Yes.
If we were working with the inverse of cosine, then we couldn't go in the third and fourth quadrants, correct?
That's right. Inverse cosine, the restriction is between 0 and pi. So it'd be first and second only, no 3 or 4. Yep. Okay, so why do we do all that? We did all that because now we can figure out anything we want about alpha. And the things that I want to know about alpha are what's sine of alpha and cosine of alpha. So I already knew that sine of alpha was 4 over 5, right? I already knew that. But now I know what cosine of alpha is. Cosine of alpha is the x coordinate over the radius. So it's 3/5. So I have the 2 pieces of information I need to figure out that blue part, right? Same thing now with beta, right? We got to just go do the same exact thing with beta. So for beta, I know that beta is inverse tangent of 3/4. So that means that tangent of beta is 3 over 4. And I know that with tangent, again, we can't be over here. And tangent is positive, right? 3/4 is positive, so I can't be here. So this must be, let's see, 4 here and 3 here, because tangent is the y over the x. And now if you solve for r, right, r squared is x squared plus y squared. I'm going to let you do this. You should get 5. And that means that sine of beta would be the y over the r, and the cosine of beta would be the x over the r. Do I need to show the solving for r? Do y'all understand this by now? Okay. All right, I think we have everything. Now we have this and this. Those are, where are they? Here and here. So just plug everything in now. Okay, sine of alpha, 4/5. Cosine beta, 4/5. Minus sine of beta, 3/5. Cosine alpha, okay, 3/5 again. That's fun. Okay, 16 over 25 minus 9 over 25. Is 7 over 25. Okay, feeling good? If sine of theta is negative 3/5, and theta is between pi and 3 pi over 2, then find cosine of 2 theta. Okay, so I could start trying to like maybe draw things, but what about cosine 2 theta? What is cosine 2 theta? Here we go. Here's what it is. Cosine of 2 theta, or 2x, is equal to one of three things. We get to choose. Which of those three things do you think we should choose?
One
First, second, or
minus
third?
2 sine theta.
Yeah, this one right here. Because this says to know what cosine of 2 theta is, you would only need to know what sine of theta is. And that's what we were given, right? So I'm actually not going to have to do much work at all in this problem, because I know that this is equal to 1 minus 2 sine squared theta. Now remember, that really means 1 minus 2 sine theta squared. That's what this means, right? So I know sine theta. It's given to me in the problem. Sine of theta is -3/5. So this is going to be 1 minus 2 times 9/25 when I square this. And this is 1 minus, let's see, 18 over 25. Just put the 2 up top with the 9. Common denominator, 25 over 25 minus 18 over 25. 7 over 25. There we go. Didn't need a reference triangle, didn't need anything to kind of figure out R. I'm just boom, from there. Now, just to make sure you understand, what if the given information wasn't this? What if the given information was cosine of theta equals -3/5? Would I have done this? No, because this formula has sine in it and I'm given cosine, right? Would I just double this answer? Would my answer be -6/10? Or not, sorry, that's doubling. Would it be -6/5? I don't just multiply this by 2, right? I would have to go and use the formulas, and I would probably use the second one because it has cosine in it. So I go 2 times cosine of theta, I'd square that answer, then subtract 1. Understand? I just use a different formula. Okay, that's not what we are given, so I don't want you to confuse that. All right. Okay, so if sine of theta is -3/5, and theta is between pi and 3 pi over 2, find sine of theta over 2. All right, so sine of theta over 2, do we have that anywhere? We don't, do we? But didn't I say you could write it down on here? I think I said you could add it to it here. It was the one that had the plus or minus. Square root. No? No, you can go look in your notes. But I'm going to use the fact that this will be equal to plus or minus the square root of 1 minus cosine theta over 2. Did y'all write those down? Did I say y'all could write those down? I swear I did. Maybe I didn't.
They're in our formula sheet.
Yeah. Oh, wait, they're in the formula sheet?
Yeah. Yeah. Not this one, the second.
The other ones, the other formulas?
Yes,
the
we have
ones-
a formula
okay.
sheet.
Yeah, I don't have it here because when I lost all my stuff earlier this semester, I lost that too. Okay, so it's in the other formulas. All right, great. Okay, let me give you a minute. See if you can't figure out how to do this. Basically, you need to know what cosine of theta is, right? If you can figure out what cosine of theta is, you're in business. And here's what you know. Sine theta is this. And here's your theta restriction. So take a minute. See if you can figure it out. Okay. So, did you all get what I got there? Are there any questions on how I worked this out? How do we determine whether or not our answer is plus or minus? It's not both.
Just look at what we would take. Would we not take, look at what quadrant we're originally in, and then we would go half of that.
Yeah, good. So the what we're trying to figure out is what is sine of theta over 2, right? And we know right now it's this answer plus or minus, we're not sure. But we also know that the original theta was between pi and 3 pi over 2. So if we take that and divide it by 2, divide by 2, dividing by that other one by 2 makes that a 4 down there. And that gives us what theta over 2 is between. It's between pi over 2 and 3 pi over 4. And that means theta over 2 is between pi over 2 and 3 pi over 4. It's actually like between here and here. It's somewhere in there. It's nowhere else. And that's the second quadrant. And in the second quadrant, sine is positive there, right? In the second quadrant. So that means our answer is the positive answer. Questions on that? All right, look at that next one. This is like a problem earlier. We had to solve a trig equation. It looks a lot like the one we did earlier. Let me see. It's not the same, but where is it? Here it was. Remember this? Find the solutions on the interval. 2 sine squared theta minus. Oh, that looks real similar, but it's not. Something different here. We have 2 sine squared theta equals 2 minus cosine 2 theta. So we have 2 sine squared theta equals 2 minus, okay. I want all of this in terms of sine or cosine. In the previous problem that we did earlier, I switched the sine squared over to 1 minus cosine squared. I used the Pythagorean identity, but I did that because I had cosine theta here. So if I turn this into 1 minus sine squared, 1 minus cosine squared theta, then I'd have a bunch of cosine thetas here. This problem is different because I don't have cosine theta, I have cosine 2 theta. So I think what would be better is if we went to our formulas and we use the cosine 2 theta and used one of these. And how about we use one that gets us to sine? So we just do it kind of like we did it earlier. Replace it with 1 minus 2 sine squared. So this will become 1 minus 2 sine squared theta. Replacing the cosine 2 theta with that, and also remembering the negative is going to have to distribute. Okay. That's a problem. Do y'all see what's going to happen? So if we go and subtract, get all the sine squareds over, subtract 2 sine squared theta on both sides. You'll have with 0 equals 1, which isn't true, which means there's no solution here. Now, I can't see myself giving you a problem like that, but I guess I did this to my students in a previous class. Interesting. Let me do something real quick. I'm just going to double check this. 2 sine x squared. And then what was the other side? 2 minus cosine 2x. 2 minus cosine of 2x. Yeah. So what I did here is I graphed the left-hand side like it was a function, and I graphed the right-hand side as if it was a different function. And so when we're trying to figure out when they're equal, we're saying where do these graphs hit one another? And you can see they never do. So there is no solution here. I just wanted to verify it. Strange that I would put that on a test, but I would not anticipate this. I would anticipate at this point that it would turn into something more like this. Like once we do the substitution, you'll have to do like probably a factoring or something over quadratic or all right, so we've got triangles. So this is more recent stuff. Let's do this one. This might be the last one of the day here. So I give you that A is 6, B is 8, and angle B is 32. So how do we go about this?
I would start by drawing the triangle, and then we can move on to our laws of sines.
So it's kind of an arbitrary triangle, right? I mean, I can try it. Let me see. I'm not saying that any of this is going to be correctly drawn. Let's say that that's B, let's say A is 6. And we know angle B is 32. No, that doesn't work. My picture sucks. Angle B is 32 degrees. That is not 32, but we'll just go with that, okay? So we need to get all the angles and all the sides. And it's not a right triangle necessarily. So what first?
I would start with the law of sines, and we'll figure out sine big A.
Yep,
And then
I'm gonna
we
go,
have
let's go find big A, because we know little a and we know we know capital B, we know little b. So everything in yellow we know. The only thing we don't know is capital A. So I'm gonna go sine capital A over little a, which is 6, must equal sine of 32 degrees over 8. And then I didn't realize my video wasn't on. Now I'm going to just multiply both sides by 6, divide by 8. Get my calculator out. 6 sine of 32 divided by 8. I get sine of A must be 0.39744, something like that. And now I'm going to do inverse sine on my calculator, which is danger time, because you can get an angle. A is 23.42 degrees. Okay, this is the part that was kind of weird in the homework, and that is we have what we said is that sine of some angle A is 0.349. Now sine is the y coordinate, so we're saying that that angle could be here because that y coordinate could be 0.3974, and our calculator told me that that angle is 23.42 degrees. But I could also be over here where I would have the same y coordinate 0.39744, and that angle I have to figure out. So what I can do is realize that the magnitude of this and this are the same, so I take 180. So to figure out what that angle is, I take 180 and subtract 23.42 degrees. Does that make sense to everyone? Because I think that's one of those trouble areas. 156.58. Okay. So the angle A could be this, or it could be 156.58 degrees. What I'm going to check real quick to see is if this is possible. Is this possible? Well, the other angle B is 32, right? So what happens if I add 32 to 156? That's bigger than 180, isn't it? So this is impossible for this to be here, because when I add it to the 32, it just makes it more than 180, and the sum of all angles has to be 180. So we only have one solution here. We know angle A must be 23.42. So from that, I can figure out what angle C is. C should be 180. Take away the 23.42. Take away the 32 that we started with. And I'm getting angle C must be 124.58 degrees. So as of right now, I have all the angles. And I almost have all the sides. The only side we don't have is little c. So to get little c, I'm going to go stick with law of sines. I'm going to go little c over sine of capital C equals little b over sine of capital B. C, sorry, we know angle C is 124.58 degrees. So this means that C is 8 times sine of 124.58 degrees over sine of 32 degrees. Calculator time. $12.43. So now we have all the sides. We have A, we have B, and we have C. All the angles, all the sides. All right, we still have another one. That's probably law of cosines. And then length of vector, angle between vectors, converting from Cartesian to polar, converting from polar to Cartesian, partial fraction decomposition. That was the first thing we covered in this class, partial fractions. And that's it. That was the final that I gave in 2017. So yeah, we'll come back. I'll finish this off, and then I'm going to email all of you a different review. Just be careful on the review I emailed to you. There are a few problems I'm going to tell you not to do because they had to do with parabolas and ellipses. So I'm just going to say don't do those. But I'll email that to you here in just probably in the next 10-15 minutes. And I'd work on that. And then when we come back on Wednesday, I really want to just address questions like, hey, I'm having trouble with this. Could you do another example like this? Or could you explain this? I don't want to do what I did today where I just work through another review. Okay, I really want to address people's concerns. All right.
Yeah, I was just looking at the homework and there's a bunch of like 6 somethings with no due date. We're not going to do those, correct?
Yeah, the 6, let me see, 6 point something.
I have it here, 6.3, 6.4, 6.5, 6.6.
Yeah, don't do those. I actually don't even know what sections those are.
Okay.
Yeah, all of those assignments actually they were like, everyone who does pre-cal, there's a pre-calculus lead instructor who creates all those assignments, and then we just copy them into our course. Okay. So
and
I'm not sure what those are.
Ignore 11, 11.2 and 11.3 as well.
Yeah, I'll go in there and I'll just take them out so that they're not showing as being due.
Okay. Perfect. Thank you.
Yep. Any other questions? Okay, everyone. We shall see each other soon. Have a good day.
Thank you.
Bye. Thank you. Have a good day.
You too.